Hey everyone, Mr. Skelton here, back at it, lesson 4 for unit 6, and today we're going to be talking about more vocabulary words. This is the first one today is the median, and so a median, I'll call it vocabulary word number 1 for the lesson. A median is a segment that has an endpoint on a vertex and opposite side midpoint. So I'm going to show you what that looks like here. So that is a vertex. So a median will start at a vertex, go to the opposite side, and its opposite side when it meets is a midpoint. So it looks like that. That's what a median looks like. So you're going to need to be able to recognize them. Okay. I'm going to draw another one in here. So here's the other vertex. If I go across, again I'm drawing this by hand, so bear with me. So when it crosses the other side, it cuts that other side in half. Okay, I'll do a third one here for you. 1, 2, 3, and 1, 2, 3. Okay, so those are 3 medians. Now the second vocabulary word for today's lesson is the centroid, and that is this point right here. So the centroid is where the medians meet. Okay, or where the medians come together. We call that the point of concurrency. Point of concurrency is where they meet. Okay, so this point right here, I'll call it C. That's your centroid. That's where all the medians come together. Okay, now with the centroid, you see this box right here. There's a theorem that goes along with a centroid, and the centroid theorem basically works like this. If you look at this picture, you'll notice that this distance, I'll label this, I'll call this A, B, and C. Or I shouldn't say A, B, and C, I'll call that one D, because I have C in the middle. But if you look at the distance from A to C, okay, I'll label that one E, call that F, and I'll call this G. If you look at AC compared to CE, obviously AC looks longer, and you'd be right. Look at this, D to C compared to C to F. D to E, or D to C is longer. B to C compared to C to G is longer. And there is a theorem that relates these lengths with medians, and it basically works like this. I'll use this picture up here to kind of show you. I'll use BG for example. So BC, that length of BC, which is right here, from B to C, equals 2/3 of the length of the entire thing, which is BG. Okay, now that may be a little hard to understand, so let me just kind of show you what I mean. If BC is 2/3, that means CG has to be 1/3, right? Because 2/3 plus 1/3 makes a whole, and so you could basically go around this whole triangle and put those in. AC is going to be 2/3, that'll be 1/3. Okay, so how can you apply this? Let me show you right here in this box. It says ABC, DE is 6. So DE is 6. So if that length is 6 right there. Thank you. Darius, you here? No. Sorry about that. If DE is 6, so that's the 1/3. All you would do to get from 1/3 to 2/3 is just times that by 2, so that has to be 12. So if you know BD is 12, that's 2/3 the length of DE, so if that's 12, you just cut it in half, that makes that 6, and vice versa. Okay, so it says to find BD, which would be 12, BE, which would be the entire length, would be 18. It says AH is 11, so if AH is 11, you're just going off the markings. BH would have to be 11, because this has 3 tick marks and this has 3 tick marks. That means AB would have to be 22. Okay. Let's look at example 2 here. It says WM is 16. Okay, if I'm looking at WM, which is this distance right here, I know that MX, which is the remaining part of this entire median, if this is 2/3, that means this is 1/3. So if this length is 16, you just cut that in half and get 8 here. So MX has to be 8. So MX is 8. WX would be 16 plus 8, which is 24. Okay, it says RZ RZ is 18. Now this part is a little tricky. R to Z is 18. So if you know that R to M is 2/3 of 18, what would that be? Well, you could think of this in a couple different ways. You can break down 18 into thirds by dividing it by 3, right? And you get 6, 6, and 6. So 12 and 6. 12 plus 6 makes 18. So MZ would have to be 6, and MR would have to be 12. Okay? So again, that's the median stuff. And that's very basic math that you'll have to do, and that's as hard as they're going to get. They don't get much more difficult than that. All right, so the third and fourth vocabulary words, let me move this up here for you, is an altitude. You've heard this word before, but an altitude basically has two endpoints. Okay, it's going to start at a vertex, and then it's going to go to the opposite side and is perpendicular. So you got to be careful, because a lot of students will look at an altitude, and because they see the perpendicular, they see that 90-degree mark, they think that's going to be a perpendicular bisector, which you saw last lesson. You just got to be careful. So please understand, and please try to understand the difference between a perpendicular bisector and an altitude, because they look similar. Okay. Now, with altitudes, you have three situations here. Basically, you can have altitudes that are inside of a triangle. So that's the first box. You can have an altitude that is an actual side, okay, like a good old-fashioned right triangle, which you have here in example 2. And then obviously you can have an altitude that is outside of the triangle. So I showed you those three examples just so you can get a visual and kind of see where you may see altitudes in some pictures. Following our theme of giving you the type of line and then where they meet, the orthocenter is where the altitudes meet. Again, we call that a point of concurrency. That's the more technical term, but altitudes meet at the orthocenter. Medians meet at the centroid. Okay? I got to bump back because there's one thing I forgot to mention on the centroid. This is important because you'll see this on a quiz or a test. One thing that is known, if you look this up online or Google it, kind of a fun fact about a centroid, we consider that to be the center of gravity on a triangle. What I mean by that is like if you had a triangle and you had medians all on them, this middle point right here, the centroid, if you took a piece of string and hung it from like the ceiling or somewhere in your room, that triangle would be parallel to the floor. It would hang perfectly. It's the center of a triangle. And that's something that's like a good quiz question I usually ask, like, what is the center of gravity on a triangle? You would have to know that that's the centroid, okay? Or I could give you an example like, hey, I have a model airplane that I constructed over the Christmas break or whatever, and I want to hang it from my room, but I want to make sure the model airplane is not, nose down. I want to make sure that it's parallel to the ground. Where would I hang where would I put that string on the model airplane? That would be the centroid, okay? So I want to make sure I told you that. All right, on the back is basically just a bunch of review, okay? We're kind of mixing everything together, all these vocabulary words we've had over the past few lessons, so let's just take a look at these. This can be a little overwhelming, especially this first picture, because there's a lot of information. So we want to name an angle bisector. Obviously for me, when I look at this question, I'm looking for the markings, like where are my angle bisector markings, and I see them down here in the right-hand corner. So I know that I just start at B. Where does B go to? E. I know that BE is the angle bisector. It's cutting angle B in half. Number 2, a median. So we just talked about a median. And so again, with the median, you're looking for a segment that is going to cut the opposite side in half. Now a lot of students for number 2 will put AC, but that's not a median. Obviously C, you can see the tick marks here at the bottom. So go from C and go backwards. FC is the median. Okay, FC is a median. It starts at a vertex and goes to the opposite side. Your perpendicular bisector, a lot of students miss this, or they think it's not possible, but actually AC is a ray. It starts at C. Actually, I would call it CA. CA is a ray. And perpendicular bisectors don't have to start at a vertex. They can kind of appear or show up anywhere. So that's your perpendicular bisector. Your altitude, again, a lot of students will put CA here, but DG. I always look for altitudes, those 90-degree boxes. You can see it there up at G. So DG is your altitude. Okay? Same type of question for 5, 6, 7, and 8. We'll run through these here pretty quick. You're just identifying them now instead of kind of like I have the choices, you have to tell me what they are. So it says identify as a perpendicular bisector, an angle bisector, a median, or an altitude. So ST, if you look at ST, starting at S going to T, all you have is perpendicular line there, so that's an altitude. Number 6, UW. UW, if you look at UW, where W hits, it cuts that side in half, so that tells you that that's a median. On 7, BD, BD is an angle bisector. You see the angle bisector marks. Line N, again line N, you have a 90-degree mark and you have tick marks next to it, so that tells you that that's a perpendicular bisector. Okay. Now, here's some questions that you'll see on homework. You'll see these on a quiz, kind of asking you kind of the questions that I was asking you earlier about center of gravity and where would you put things, and some of these you'll notice carry over from the lesson we just did. So number 11 says, city planners want to locate a fountain equidistant from the 3 straight roads that enclose a park. How would they find the location? Well, if you remember, we talked about where would you want to put a dot or a water fountain or something on 3 lines. So that would be the actually be the in-center, okay? That's going to be your in-center. Now some of you may not remember, but remember the in-center is the same distance from all the sides of the triangle, okay? And in-centers are created by angle bisectors. Number 12, the town of Adamsville, Brooksville, and Cartersville want to build a library that is equidistant from the 3 towns. Well, here's the picture down here at the bottom. So if you connect these dots and just make a triangle, what is the center that we should build at? That's the circumcenter. Remember that the circumcenter is equal distance from all of these points. That's the circumcenter, that's equal distance from all 3 points. 13, a small park has 3 pieces of playground equipment, a slide, a swing set, and monkey bars. Families have collected enough money to install a drinking fountain. Parents want the drinking fountain to be equal distance from each piece of equipment. So again, this is just identical to the one we just did. You have 3 points. You want to put something right in the middle from those 3 points. That distance from the water fountain to each piece of playground equipment is created by a circumcenter, because circumcenters are equal distant from 3 points. Last one, suppose 14, you want to hang a model airplane. We kind of just talked about this. You want to hang a model airplane from the ceiling so that it stays upright and horizontal, which means parallel to the ground. You want to find a point in which to hang that triangular shaped stealth bomber model, which is down here. So what would you need to hang? That would be the centroid, because the centroid is the center of gravity for any triangle. It's going to hang parallel to the ground. Okay? So these are kind of a collection of everything we've done over the past few days, especially this mixed practice. So if you can identify the angle bisectors, the medians, the altitudes, the perpendicular bisectors, you're going to be ahead of the game. So if you have any questions, let me know, and I'll see you in class